Start out with a question. How many folks have ever heard of disinfection byproducts? Good. Good. So, I'm the disinfection byproduct rule manager in the state, and what we deal with is exactly what it says there: the byproducts from disinfection. We all want to have safe water to play in. I don't know if you've ever been there. This is the Queen's Bath on the North Shore of Hawaii. It's real safe unless a wave comes in and takes you out to China. It's a beautiful place. We all want safe water to drink. So this is our goal. Consequently, we must inactivate the harmful pathogens that are introducing by introducing disinfection. Disinfection is our best friend. Chlorine is our best friend. We have other disinfections, but chlorine is our best friend. However, this could lead to other issues. For example, we can talk about having precursors in the water. That would be like any organic material in water. If you add a disinfectant to the organic or the precursor, you can end up with some DBPs, disinfection byproducts. So that's my rule, that's my title, DBP rule manager. Well, it's the disinfection byproducts. Organic materials, anything that's got carbon in it is an organic material. We add chlorine to it, we get one of these types of things, trihalomethanes or halocetic acids. Now we regulate those 9, 4 of these and 5 of those. 4 trihalomethanes, 5 halocetic acids. In order to prevent disinfection byproducts from being created, we want to remove the organic material, simply because the organics plus the chlorine make the disinfection byproducts. So by removing the organic material and maintaining a level of chlorine that's not too high, because too much chlorine and too much organic can produce disinfection byproducts. Factors that affect it are the precursors, the total organic carbon, that's what Lisa will talk more about. Disinfection type, and then to keep a balance between the disinfection and the byproducts that are uniform. The pH of the water is very, very important. The chemistry of the water, the water temperature, and the residence time. In other words, how long the chlorine is in contact with the water soluble. We have to keep this balance right here. The balance between the disinfection and the disinfection byproducts produced. Again, if you have too much organic and too much chlorine, you're going to have disinfection byproducts. If you remove one or the other, that's fine, but if you remove the disinfection, you're defeating all our purpose, because that's what's inactivating all our pathogens. We have 2 groups, the trihalomethanes, which we have 4, and the halocetic acids. This is a picture of a methane molecule. The methane molecule has 4 hydrogens around it, but these hydrogens can be replaced with one of the halogens, mainly chlorine or bromine. Bromine could be naturally, exists naturally in the ground. Halocetic acids are an acetic acid molecule, which the hydrogens can be replaced with chlorine or bromine. So, again, we have 4 of these, 5 of these that we regulate. There's possibly 600 types of disinfection byproducts can form. But if we get these, we're getting rid of the others. So how are we controlling these? By controlling your organics and chlorine. The regulated DBPs, there they are. The 4 that we look at, the trihalomethanes, there's their formulas and there's their names. Then we have 5 halocetic acids. There they are. So the reason I showed you all those is because the Cube water system, we've been collecting data since 2004. That's when the disinfection byproduct rule came into effect. And it looks like the Butte water system looks pretty good on tri-halo methods. The haloacetic acids are higher. So, I'm sorry, they're higher. Let's take a look at the haloacetic acids in the Butte water system. I've got this table here, and I know, I probably should have rounded off numbers, but these are the actual values. I'm going to spend a little bit of time on this chart. My rule, the stage 1 disinfection byproduct rule states that we look at the values for the last 4 quarters. You can have a high quarter, and you usually do in the summertime. But we look at the last 4 quarters, and therefore that's what your compliance is run on. You can be pretty high, but your compliance for that quarter is not going to be high. So, in other words, the running annual average of 4 quarters, starting from quarter 4, 2006, down to the current time here, is what I looked at. I pulled out all the data for 5 years. Now, the ones that, I forgot to tell you, the maximum contaminant level is 60. That's the number we're trying to stay less than. EPA has designed, set this standard of 60. If you go beyond that, then you're exceeding the limit. Basin Creek has some pretty high values. In other words, if you took the 5 years there, the ones that are in yellow, red, yellow here, those are quarters that the average of the haloacetic acids exceeded 60. If you took a look at the Big Hole, which is a filtered system, it also had higher HA5s, haloacetic acids. The molten plant had 4. So we had 12 here, 6 here, 4 here, and if you looked at the quarter averages, yeah, they would be pretty high of those numbers. However, again, the rule states that we take a look at the running annual average of the last 4 quarters. So, going along, the rule was adopted in 2004. Here we are. I got data back for 5 years I looked at, and you did not exceed the MCL of 60, the maximum contaminant level of 60 parts per billion, until quarter 3 of 2010. And what the running annual average was 60.6, barely over the 60, but it was there. Right here, again, but they had 2 violations, and that was it. Right now, the running annual average is down pretty low. However, the Basin Creek has been off, so that one hasn't been contributing. These numbers right here are false because they're taken from the place where they normally, the sites where they normally take the sample, and the Basin Creek is not, it wasn't running at that time, it is now, but it wasn't running at that time and it was really low. So, to summarize this, there's 4 sites that deal with Basin Creek, 4 sites that deal with Big Hole, 4 sites that deal with Bolton, and the running annual average is calculated over here. Now this is under stage 1 disinfection byproduct rule, which says that Butte can take, well, they have 3 sources, so they have to sample it quite a bit. And the rule states that they have to take 12 samples every quarter, which is quite a bit. However, it's helped them in a few places because the running annual average, when you take an average of 12, it usually gives you the advantage. In 16 more months, the stage 2 disinfection byproduct rule will come in. Now that says you will only have to test 4 sites. The 4 sites that are chosen are going to be the ones of highest history for TTHMs and HA5s. And it's also going to be a locational running annual average of each site. So therefore, they won't be able to take all this. So what I'm trying to say here is this, that whether you have an unfiltered system or a filtered system like these two, the DVPs have to come down because with stage 2, it's going to be harder to stay under that 60. So that is kind of a summary. I know there's a lot of numbers up there, and maybe if I go to the